Welcome to our channel. Today we're diving deep into the cosmos, exploring the most baffling, the most mystifying signals that have ever pinged our telescopes here on Earth. We're talking about bursts of energy that make our sun look like a flickering candle, patterns of light that defy explanation, signals that pop up once and vanish like a phantom. So buckle up. Get ready for a wild ride because we're about to embark on a quest for knowledge, a cosmic exploration into the unknown. Imagine this, a burst of energy so intense it releases more energy in milliseconds than our sun does in a year. These are fast radio bursts, or FRBs. Some of the most energetic events we've detected. They're like cosmic firecrackers, leaving us to decipher what ignited them. These events happen billions of light years away, yet reach us with enough power to make our instruments sing. They're incredibly short-lived, lasting just a few thousandths of a second. Most don't repeat, making them harder to catch and study. What causes such powerful outbursts? That's the million-dollar question. Ideas include colliding neutron stars, collapsing black holes, even advanced alien civilizations. We're still in the early days of understanding these cosmic enigmas. Back in 1977, amidst the disco balls and bell-bottoms, a signal from space made its way to Earth. A signal so peculiar, so strikingly unique that it earned a simple yet profound annotation on a printout. Wow, this, my friends, is the story of the wow signal, a signal that has tantalized and frustrated astronomers for decades. Picture this, a young astronomer, Jerry Amon, sifting through data from the Big Ear radio telescope in Ohio, searching for any sign, any whisper of extraterrestrial intelligence. And then boom, there it was. A 72-second burst of radio waves, stronger than anything they'd ever seen before, originating from the constellation Sagittarius. Was it a glitch, a stray signal from a passing satellite, or was it something more, something extraordinary, a beacon from a distant civilization trying to make contact? The mystery remains a tantalizing puzzle that continues to fuel our imaginations and our desire to explore the unknown. Let's talk about a star that has astronomers scratching their heads and science fiction fans buzzing. This is Tabby's star, also known as Boyajian's star. Stars dim and brighten, but Tabby's star dims in a way we've never seen before. We're talking about dramatic irregular dips, sometimes by as much as 22%. Could it be a swarm of comets, a massive ring of dust, or a Dyson sphere, a hypothetical megastructure built by an advanced alien civilization? Now, I'm not saying it's aliens, but it's a possibility that has captured imaginations. Further observations suggest dust, but the mystery isn't entirely solved. Let's rewind the cosmic clock back to 2007, a time when flip phones were cool and the first iPhone was about to change the world. While we were busy texting and taking blurry selfies, a team of astronomers led by Duncan Lorimer stumbled upon something truly groundbreaking: the first ever detected fast radio burst. This signal, now known as the Lorimer burst, wasn't just another blip on the radar. It was a powerful, incredibly brief burst of radio waves originating from a galaxy billions of light years away. It lasted a mere 5 milliseconds, but in that fleeting moment, it upended our understanding of the cosmos and opened up a whole new field of study. The discovery sent shockwaves through the scientific community. It sparked a flurry of research. New telescopes were built, and existing ones were repurposed to hunt for these elusive signals. Nestled in the quiet hills of West Virginia sits the Green Bank Telescope, a behemoth of an instrument, a giant ear, listening to the whispers of the cosmos. And in 2017 it picked up a signal that, while not as loud as the wow signal, was intriguing nonetheless. This signal, originating from a galaxy about 3 billion light-years away, was faint but persistent. It wasn't a one-off burst like many of the signals we've discussed. It repeated, pulsing with a steady rhythm, almost like a cosmic heartbeat. What makes this signal so fascinating is its frequency. It falls within a range known as the waterhole, a relatively quiet band of the electromagnetic spectrum where radio waves from hydrogen and hydroxyl molecules, the components of water, are prevalent. It's thought to be an ideal spot for interstellar communication, a cosmic meeting place for civilizations trying to reach out across the vastness of space. The Kepler Space Telescope, a planet-hunting powerhouse, has revolutionized our understanding of exoplanets, but it's also stumbled upon some pretty weird stuff along the way. We're talking about stars that exhibit unusual light curves, patterns of dimming and brightening that just don't add up. Imagine a star that dims, not just a little, but by a significant amount, and then brightens again, only to repeat the process a few days, weeks, or even years later. These strange light curves have led to some pretty wild theories. Some astronomers believe they could be caused by massive swarms of comets orbiting the star, blocking its light as they pass by. But then there's the more intriguing possibility, the one that gets everyone talking: alien megastructures. In the realm of SETI, the search for extraterrestrial intelligence, few signals have generated as much buzz as HGB 02+14a. Detected in 2003 by the SETI at Home project, this signal, though faint and fleeting, ticked a lot of boxes for a potential alien transmission. This signal, originating from a region between the constellations Pisces and Aries, was narrowband, meaning it was concentrated around a specific frequency, a characteristic often associated with artificial signals. Was it a glitch, a stray signal from a distant satellite, or a previously unknown astronomical phenomenon? Or could it have been a fleeting glimpse into another world, a whisper from a distant civilization that we just happened to overhear? Fast forward to 2020, and the Breakthrough Listen project, a privately funded initiative to search for techno-signatures, detected a signal that sent ripples of excitement through the scientific community. This signal, dubbed BLC-1, originated from the direction of Proxima Centauri, the closest star system to our own. Now, Proxima Centauri is no stranger to intrigue. It's home to Proxima Centauri b, an Earth-sized exoplanet orbiting within the star's habitable zone, making it a prime candidate for the search for life beyond Earth. So, when a signal was detected coming from that very direction, well, let's just say it got people's attention. BLC-1 was narrowband, a characteristic often associated with artificial signals, and it exhibited a drift rate consistent with a signal originating from a planet orbiting Proxima Centauri. However, as with many of these signals, caution is key. Remember how we talked about fast radio bursts being mostly one-time events? Well, FRB 121102 decided to break the mold, becoming the first ever detected repeating FRB, and in the process, it threw a cosmic curveball at our understanding of these enigmatic events. Imagine a signal so predictable, so consistent in its unpredictability that it practically sets an alarm for astronomers around the world. That's FRB 121102, a signal originating from a dwarf galaxy billions of light years away. A signal that pops off a series of bursts, goes quiet for a while, and then repeats the whole cycle again. This repeating nature has given us an unprecedented opportunity to study these bursts in detail. But here's the thing, while FRB 121102's repeating nature has provided valuable insights, it's also deepened the mystery of these bursts. Our final cosmic mystery takes us to the Perseus Cluster, a massive gathering of galaxies about 250 million light-years away. It's here that astronomers detected an unusual X-ray signal, a signal that some believe could be the long-sought-after signature of dark matter. Now, dark matter is one of the biggest mysteries in astrophysics. It's this invisible substance that makes up about 85% of the matter in the universe, but we've never directly observed it. This X-ray signal, however, has some scientists excited. It's a faint but distinct signal, a spectral line at a specific energy level that doesn't correspond to any known particle or atom. Could this be the sound of dark matter singing? Some theories suggest that dark matter particles could annihilate each other, producing X-rays at a specific energy level. And this signal from the Perseus cluster just happens to match those predictions. More observations and analysis are needed to confirm or refute this dark matter connection. From the fleeting whispers of fast radio bursts to the tantalizing enigma of Tabby's star, we've journeyed through the cosmos, exploring some of the most mysterious signals ever detected. As we continue to develop new technologies, to build more powerful telescopes, and to listen more intently to the cosmos, who knows what other secrets we'll uncover? Perhaps one day, we'll finally have an answer to that age-old question. Are we alone? Thanks for watching. If you enjoyed this journey through the cosmos, don't forget to like, subscribe, and hit the bell icon for more fascinating space content.